mean, we can keep it interactive, it's fine. It's only a small group, not going to pretend like as though it's a big presentation. So maybe, lady here, you are?
I'm more with operation in a software.
Operations, software.
Gentleman here, maybe?
Don't know. Part sales, part engineer, part don't know what.
Okay, interesting.
Sir?
PhD from INSEAD.
Interesting. So we've got a whole profile. PhD in... Gotcha. Okay. Is there anybody else that wants to introduce their use case so I can at least tailor the presentation towards the general audience? No? Okay. So I've been given the thumbs up now. We can go ahead and proceed. So as I was saying, my name is Mano, CTO of Otonomos. Has anybody heard of Otonomos? Maybe that's the first question. Okay, half the crowd, interesting. So for the rest of you, in one line what we do is convert some part of the Companies Act, specifically your private limited company constitutional documents or the rules in the constitutional documents into smart contract. I'll go into a little bit more detail perhaps. Okay, so maybe another thing I need to find out, how many of you actually know what blockchain is or what smart contracts are or what Ethereum is? Maybe that's a good place to start. So everybody knows blockchain, everybody knows smart contracts. Does anybody need an introduction? No? Okay, great. Okay, so I'm just going to assume generally everybody is aware of Ethereum, you know smart contracts, you know blockchain. But if at any point in the presentation you feel like you need to ask questions, please feel free. I've got 30 minutes. Oh yeah, Gaurang. Good question. Excellent question. I was hoping somebody would pick that up. FITW for us means first in the world. We don't believe in building anything that somebody else has built and rehashing it. So we're not in the standard fintech use cases, if you would. It was very important to me that, so I was not the guy with the original idea. It was Han, our CEO. He had the original idea of representing private limited company shares on the Ethereum blockchain. Was a great vision. Then I met him more than a year and a half ago, and at that point he was looking for a person that could actually build the backend, right? I wasn't CTO from day one, but eventually I became one. So the idea was, how do we represent private limited company shares on the blockchain? Now, when I read up about Ethereum, and I did a few other projects before. I used to be a quant trader. After my quant trading experience, I worked on some blockchain related projects, and then I came to meet Han and the idea behind Otonomos. Then I figured out Ethereum, and I was hooked. I was like, okay, this is cool. Ethereum holds great promise for a lot of use cases, but the most obvious use case was with regards to private limited companies. Why? Because if you know law, I mean, I'm not a lawyer myself, but if you know law, you would appreciate the fact that law typically is not accessible to most of us, right? So law has to be interpreted by lawyers, and we approach lawyers then to do things. But in the corporate law space, or specifically even a more subset of that, in the corporate action space, it's very standardized. It's very rule-based. So if you were at any point trying to convert law into smart contracts, you're going to first attempt to do that via this use case, via the private limited company constitutional rules use case specifically. And that's basically when I said, look, we can do a lot more than represent private limited company shares. We can represent the constitutional rules that a company has, because you can imagine me holding common shares in Otonomos represents a set of constitutional documents in the back end. I don't just come to hold shares just because I execute a trade, right? It's actually me signing a share transfer form as a recipient. It's me, a board resolution having been passed to accept the share transfer from whoever to me, or a share issuance process. So it's a trail of corporate action documents that need to be executed on the back end. So really our innovation is in that space. And we call ourselves the blockchain charter company, not to be confused. It's not a legal term like private limited, for instance, but it's how we see ourselves. And let me go into a bit more detail there. And the pointer will not work when you need it. Guys. Maybe we need manual intervention. Okay, so while we wait for that, what I'm going to show you in the next slide, maybe I'll start describing that so that you can picture blockchain. So blockchain chartered company, right? That's where we left off. What are we trying to say here? You've got, if you look historically, and you look at the evolution of private limited company. Okay, so it should work now? Great. Okay, excellent. So there you've got the timeline, right? So the first charter company started during the global trade revolution. That was the sort of the 1400s, 1300s, if you would. Basically, they were merchant ships. Merchant ships that were traveling the world and selling stuff from different parts of the world, right? And that's where the first charter company started. And then the first company to issue shares was the Dutch East India Company. We all know that. That was in the 1600s. And that basically drove the next step, which was the heavy industry and technology revolution that started as a result of war, post-war period, and until today there's been very little innovation in the actual legal structure of a private limited company. So the modern day corporation is not that different from some of these post-war industry companies, if you would. And we came out and said, oh look, so I use another analogy here just to bring this message across. You go to a hospital today, you go to an ER room, and you compare the ER room to, say, I don't know, 50 years ago. How does the ER room look today? It's got technology everywhere. Everything is practically electronic. You want to go for a surgery, it's all keyhole surgeries these days, they're computer aided. But there is one industry where you simply do not have technology, do not have IT. And that's the legal field, right? And that's what we correctly identified, and we said, you know what, we can't do this probably for the more fancy parts of the law, but at least we could do this for company incorporations. So we label ourselves as the blockchain charter company, not because it's a legal term, but rather because we've put in this sort of automation in the back end, secure pipeline in terms of execution of documents and transacting in corporate actions. And so we decided that, you know what, this warrants its own term, and that's how we came up with the blockchain charter company. And hopefully, we are able to transcend that legal automation to other parts of the law industry as well. And then perhaps tomorrow, when we have a socioeconomic revolution, where we all think differently, act differently, and we are completely altruistic in nature, then we can think about stuff like decentralized autonomous organizations. I don't know how many people know. Does anybody know what a DAO is? Okay, great. Okay, good. So the DAO was a great first attempt, the DAO was a great first attempt at trying to build a completely distributed autonomous organization. But unfortunately, society, I don't think society was ready for it, right? And hence the hack. I'm sure you guys know the rest of the story. With that, so the one slider about Otonomos, I really came today with the aim that I was hoping not to pitch Otonomos, because we pitch Otonomos quite often these days. I wanted to speak more about, so what does blockchain really mean to us, right? And for you to understand what blockchain really means to us, you first need to understand Otonomos, unfortunately. So that's what I'm going to go through now. But if any of you have the question in your head, why blockchain? At any point, if you want to ask that question to me, please feel free. But I'm hoping that by presenting this, at the end of the day, you will realize that we are not just a company telling you that we use blockchain for a specific use case. Blockchain goes beyond our application. It's also, simplistically put, it reduces the cost of running a business, in all honesty. So even for Otonomos itself, not just for our clients, right? And hopefully you sort of get that message at the end of the presentation. But if you have questions, please feel free to ask me as we go along. We pride ourselves in having a nice balance between a commercial proposition. So we've been funded. We did a decent seed round. We were oversubscribed with some major investors. We've got a solid revenue model, because the revenue model is actually quite traditional. We are still a corporate services provider. So that part of the business model is very traditional. And we've got people, and we collaborate with a lot of interesting people like Attores, like Digix, and beyond. So that part, we've got it covered. On the tech side, so we are still a technology company, right? So we do everything from, even if we have to develop the underlying architecture, in this case Ethereum is already well developed, so we don't have to do much. We might have to do slight modification. But beyond that, on the application side, we've done a few things well. First is our identity solution. You would have heard the identity solutions from the Consensus guys, and a whole bunch of people are working on identity. We simply was not our main use case. We built it because it needed to work for our use case. But even then, because we are such NRX, if you would, We built it in a decentralized model, right? So I will go through that in a bit and show you how we do that. And the last bit is the legal automation. So automation not just driven through smart contracts, but looking at the entire business process. Anybody can build can easily build a DAO smart contract, but it is more difficult for you to build a fully automated corporate action process, right? And that's sort of what we've done. Now, I'm not going to go into very much detail about why blockchain. I'm sure, again, there are no newbies in the crowd, so you know why blockchain. But again, I'm just going to reiterate the point that why we use blockchain is for a range of reasons. The traditional world is highly centralized. Actually, I got to correct that. Originally, we were not centralized. We were very peer-to-peer. Back in the day, if you do an analysis of the history of cash, you can always prove, or you will appreciate the fact that people used to be very peer-to-peer, right? They used to do barter trades. You were not dependent on central banks to issue currency for you to be able to do efficient goods exchange. But today, we've gone to the centralized model where everything, the law, monetary system, education, despite the advent of the internet, is still a very central process. You've got curriculum, you've got teachers, and then you have students. And often, that is how you acquire knowledge, which is quite sad. So we're trying to revolutionize that, but not for everybody else, at least internally as a company. And we do that in many ways. So the way we deal with identity, for instance, which I'll show in a bit, it's also innovative from a data protection standpoint. We don't have to do data protection audits, which is a big deal these days, right? You need to always prove how you're handling sensitive data. And in our case, the systems design sort of allows you to move away from the need for data protection audits, to move away from giving a database administrator, who's typically the guy who holds the keys to the kingdom, right? He has got access to all data. In my case, should you decide to get access to my database, you will see that a lot of the information is encrypted. So even if you do get access to it, there's not significant information that gets lost. And that's sort of how we mitigate the need for very complex data protection, IT audits, and so on. And we reduce the overheads for us. In essence, we are able to run the company cheaper than you ever are. And in a world of increasing cost of doing business as a result of compliance and regulatory changes, I think this becomes quite important. So the current way and if you ask yourself why smart contracts, the current way we design systems is always, it's kind of funny, again, to go back to how we design systems. We design a system, and then we design in such a way that it's circumventable. Then we spend resources policing the system, so we've got law enforcement. And then we spend even more resources in punishing the deviants. You've got the prison system, which is quite inefficient. And perhaps until today, we've not been evolved enough technologically or even as a society. We needed that kind of a system. But I think today, we can move into a new kind of paradigm where with this technology, we can do audit only at inception. With this technology, you can do a self-enforcing, self-compliant, self-settling, self-reporting type of a model. And you really don't need expensive auditors, compliance processes, periodical processes. You might need the one time, or you might need to do it at change, but that's pretty much it. Now, to go into the crux of Otonomos, what do we do? Before we can even talk about the smart contract stuff, the first problem we had to crack was the identity protocol, right? So you can imagine in a company, you've got identities. You've got directors, you've got shareholders, you've got corporate secretaries, you've got a collection of people who need to do different things. Now, how did we first, so again, this was not part of our key use case, but a lot of people have approached us expressing interest in wanting to use our way of doing identity creation, verification. So I'm just going to highlight the various features. The most important one is probably the pointer on this thing doesn't work. Okay, the decentralized verification model that you see on the right. What do I mean by this? The traditional way where you would log into a website, you create an account gets created in a central database, and the database administrator basically is sort of in charge of that. It's out of the window. Here, you log into our dashboard, you create a persona, you upload your identity documents, you are completely in charge of that smart contract, nobody else, and you are the only one that can edit it. The only thing that we do is we maintain a register as a verification entity, so we call ourselves verification entity, and the admins of the verification entity basically maintain your latest KYC state, and that's what we do. So we simply put a checkbox and say, okay, I verified this entity. But we've also built in some clever features into the identity smart contract itself to ensure that it can always securely call the verification entity smart contract. So that is sort of how you get comfort that this identity has indeed been verified and it's secure. So that's how we did. And it could be autonomous. So in our case, it's autonomous as a verification entity. As a corporate service provider, we're required to do KYC and all the guys that we onboard. So we are a verification entity, but this could be banks, this could be MAS, this could even have a hierarchical structure where MAS approves DBS Bank to do source of funds KYC, approves Otonomos to do identity KYC, so it could even have that layered KYC approach. We never pushed it much, but we designed it such that it could be its own ecosystem. And then that gives you that sort of reputation model that we hopefully will go to in the future. So in the future, you hopefully get rid of that decentralized verification model and you go to a model which is more reputation based. But again, that's too much in the future, but we've sort of laid the foundation, at least in terms of the way we design stuff. And then you've got, right on the top there, peer-to-peer transaction without knowing the other party. So this is interesting. I could transact with my identity smart contract with another person, and because the other person's identity details are always encrypted, I will never know who I'm transacting with. But do I care? Maybe not. Some use cases I probably wouldn't care. Why would I not care? Or what would I care about? I would care about whether that person has been verified by somebody else. For instance, a DBS Bank. For instance, an Otonomos. So I literally could transact with people that I don't know about, and the only information I know about them is that they've been verified by a verifiable source, like Otonomos. And so we did that. And we've addressed all the key requirements with regards to privacy, replacement. So privacy, when you create your persona smart contract, and this is again how we mitigate data protection, how we mitigate the need for periodical IT audits. When you create your identity smart contract, you also upload your proof of identity and your proof of address document. And in these documents are encrypted by default with your public key and the public keys of people that you need to share the document with, just by default. Nobody else gets access to this document. So the link of that document is then stored in your identity smart contract to prove that this identity smart contract owns that identity data. Why do you have to do that? You have to do that so that when that identity smart contract signs a document or holds a share in a private limited company, then you can always prove who owned the shares, right? That indeed it was that person that owned the shares. Now, what does this do for data protection or for IT audits? It basically again means that even if my administrator gets access to the database, they're not able to see who this person is. The only people who are able to decrypt that identity data are people who are involved in the process. Fellow, let's say a company director, fellow shareholders, corporate secretary, or administrators who are actually doing the KYC check, right? And replacement, so that's also a very important thing. If you replace your private key, so you can imagine everything that's done on the dashboard, just like in the Bitcoin world, every transaction has to be done by way of a private key. So the question has always been, what happens if this private key gets compromised? So we've also put in a layer in there that allows you to replace your private key without losing association with the assets you hold or the documents you've signed, right? So that's also something we've done. And on the recovery side, so even with recovery, so in the traditional world, what would you do when you lose your password? You go and you click forgot password link. And then the system somehow resets your password or sends you your password, right? In our case, that's not even possible. What happens is you initiate password recovery because your private key, not password, forget that I said password, private key, that's more important. Assuming you lost your private key, because your private key is split into 3 parts and 3 organizations hold each part of the key, when you want to recover, 2 out of the 3 guys need to come together to be able to recover your identity. So even us as Otonomos cannot recover your private key. And why is this all important? It's important because when you prove that somebody has indeed signed the document, that you can always prove that this key could not have been misappropriated by somebody else, right? So that's why we went to that great length of making sure that we cracked every single part of this identity layer. And then with that, yeah, sure. Parts of the private key. 3 parts.
3 parts?
Yes.
So any 2 parts can form it?
Yes. Any 2 parts.
So if the 2 parts
collaborate. So you're absolutely right, but this is still better than any existing real-world solution currently today, right? There are no solutions today that even do it to this level. So today's solutions all, what do they do? There's only one encryption. So we are not a silver bullet. We just try to minimize.
There's still a chance that these two will take the private key.
Absolutely. And that's also why we chose 3 organizations and not people. So importantly, one organization is Otonomos, and the 2 other organizations should be a law firm. So you have real world contracts with a law firm to say, give them a protocol and say, look, you're not allowed to recover the private key unless you are directly instructed by the person that's recovering the private key, for instance. So you need to have that.
Can I ask,
Yeah, sure.
at the beginning when you first assign, I upload, someone have to verify what I sign and upload is equal to, I mean the document proof is me.
Yes.
Upload,
Yes.
nobody else see.
What do you mean by nobody else sees? You mean,
You upload the document, I'm the only one that can access to it. So how do you, who prove that the document that I upload proof is me? In the very first, at the very
okay, so we actually, the entire process of what we do, we don't really do document signing, right? So in our case, what happens is you create a persona smart contract. The persona smart contract is the one that signs documents. So because the persona smart contract is a holder of identity information, so it has your proof of address and your proof of identity in it. In addition to that, it also has a KYC stamp to say Otonomos has verified this smart contract. Yes.
I'm trying to say, yes, the digital document, but how does it prove that it's me that I upload my document that is me?
So we do the KYC process. So that is a real world process.
Okay, so there is someone
Oh yes,
proof that I upload,
yes, yes.
and then I get this persona.
Yes, correct. So you get your persona already. You just generate your persona, you go to the dashboard. So this is again the philosophy, right? We want to empower the end users to be able to create their own smart contracts because we do not want to do that on your behalf.
Which one comes first, right?
You will create first?
Create first.
Yes,
I upload first,
correct.
then how does,
So then your identity documents get encrypted with your own public key and my public key as an administrator of Otonomos platform. And then I will decrypt your ID address and I will check that your first name, last name that you entered corresponds with the identity document you've given. I will check your proof of address document and see that the address there matches with the proof, the address that you've entered. And if all of that passes, we even do a Reuters world check. Again, because we are a corporate services provider, we need to do this. So we do a Reuters world check and we see that you've got no red flags before we allow you on the dashboard. And then at that point, we maintain a register, which itself is a smart contract. And on that register, I basically set your state to a valid state. And all my other smart contracts have got a check in there that before you can transact, before you can sign a document, before you can transfer assets, you must have a valid KYC state. Yeah.
so do you need to see the person physically, see the IC physically, or you upload the document?
So we don't, but there's also another interesting feature that we've recently implemented, not live on our dashboard at the moment yet, it's still in development, where we take a picture, if you have a webcam, we take a picture of you as you're submitting your persona smart contract. Yeah. Correct. But of course, that assumes that you allow the camera to be activated, right? Because on the browser, you can deactivate it. But we're trying to figure out how we're going to make this work in terms of a business process. The technology is simple, but the business process is more complex. Right? Exactly. And we don't try to always solve these human-related issues, right? All right. With that, let me get into say the main use case of Otonomos, right? So this is our company smart contract design. It's really nothing rocket science, nothing revolutionary, but what really happens is we've got this thing called the company smart contract. The company smart contract is a complete representation of the company's constitutional documents, essentially. The documents that describe who the directors of the company are, the document that describes who the shareholders are, the document that describes what the signing rules are for various types of resolutions, special resolutions, shareholder resolutions, board resolutions, and so on. And then to enact a state change in the company smart contract, what is a state change? It could be adding a new director. It could be transferring shares from one shareholder to the other. There's a specific set of legal documents that need to be signed in a specific order. And that's what you see on the right side. These are the resolutions. And we've also built it in such a way that the resolution is not just something I can deploy on my own. I have to tell the resolution some basic information, being the company's public identifier, which is the contract address. And when I tell it the contract address, it's going to securely retrieve the signing rules from the company smart contract. and populate them into the resolution and just simply manage when and who can sign these resolutions. And the moment they get signed, we've got a back-end process, an automated corporate secretary. It's not really artificially intelligent at the moment. It's a very simplistic process, but in the future it could be. And then that automated corpsec will monitor the resolution, and the moment it detects, or she detects, that the resolution has been passed, it will file the resolution with the company smart contract. We really mirrored the business process almost one for one in terms of how we do this, right? So in the real world as well, the same thing happens. Our corporate secretary, so we've got a corporate secretary in the house because we're a corporate services provider, does exactly that in the real world. So without this process, she would have deployed that resolution, or she would have printed out this resolution, gone to the directors of the company, got the relevant signatures, and then filed it with Accra or filed it in her internal files, right? So the same process holds, except in this case, the resolution is filed into the company smart contract. And that will trigger the state change. Interesting question. It doesn't. But that is also why I've got this picture of an extract of a legally signed document on the dashboard. This one is a slightly older document. We've got another feature which allows people to also input their signature when they create their persona, simply because people are not comfortable with that QR code. The QR code represents the point on the blockchain where this was signed, right? So we're also adding a signature to that, just so that Accra will recognize this. Electronic Transactions Act in Singapore allows you to electronically sign documents. It's not that it's not allowed. So it is allowed. I think what is probably going to be a challenge is, at some point, Accra needs to be convinced that the company smart contract is, or the way we've designed this, is more robust than any traditional paper process way. But because we've built the bridge already, we produce a document that looks the same, and it's an extract of the resolution smart contract. They don't have anything to say about it at the moment. So it's...
EGM.
But you know what's the funny thing? So EGM, you're talking about EGM, extraordinary general meetings, or annual general meetings even. Maybe annual general meetings are a bit different, but for EGMs, right, even in today's world, the real process is people don't necessarily sit in a room to convene an EGM. So they just sign a document that basically says they've done this.
So the contract automate the signing.
Yes.
And you print a physical copy.
Correct.
To satisfy Accra.
Correct. So that's probably excellent summary. And that's also what we do best at Otonomos. We bridge the gap between how it's currently done with how it could be done in the future, with hopes that at some point we'll phase the documents out. With hopes. Yeah? Yeah, so with this, we've achieved best practice. Why? Because we give these companies a standard constitution document, standard signing rules that are based on best practices. It's incorruptible because at any point you can always prove that a specific corporate action that took place in the company smart contract was as a result of a specific ordered set of resolutions. It's automated. Why? Because we can build a corporate back-end process, that corporate secretary there, that basically can recognize, hey, these two guys have signed a share transfer form, but that's not enough. A board resolution needs to be deployed to accept the share transfer before the state change can happen in the company smart contract. So that automated process basically deploys that, right? So again, something that even in the legal world has not been done so far, and we've managed to sort of automate that. And then the last part, crypto legal substitution. At some point, it is a dream at Otonomos that we will have a crypto legal department, hopefully, where you have developers sitting next to lawyers, because at the end of the day, what we're doing is merging the two worlds together, and they need to speak to each other, make sure that when we do convert constitutional rules into code, that we're doing this correctly, and we're not making mistakes there, right? Yeah.
So I guess there's something I'm not quite clear on yet. So I understand that once a change is decided upon, you convert that change into code.
Yes.
And it goes through this entire automated process, right?
Yeah.
But isn't the key, one of the key functions of a lawyer is to decide what kind of change to enact in the first place? So I go to a lawyer and say, this
Sure.
is what I want to do, how do you phrase this, what are my options? Basically words, right?
Yeah.
Come up with a set of words that describes what I want. And then basically that lawyer, I see, you guys aren't replacing that guy at all. He then goes to you and then says, can you automate it?
So the stuff that we've automated, these are standardized documents already in the real world. They are not even custom documents.
So you
Correct. And no, not at all. Maybe we could go at some point. We could modularize legal documents. I would love to do that, but I think that's far-fetched. Let's first prove this and see this works, and then we'll definitely go there. And then the future. So it's also essential for us to always keep in mind what are we working towards, right? What we've done today is basically convert the entire organization structure, the corporate governance and all of that via the company smart contract. And where we want to hopefully go next is the finance management aspect and the marketplace. So the other pain points for a company are accounting, right? So we've already sort of decentralized at least corporate secretaries and low-end lawyers, if you would. And the next area to tackle will be finance, or will be accounting. Hopefully we get to do that. And once we've done that, what's more exciting is the marketplace, or the concept of a decentralized exchange. Now that you've got a company smart contract that has become the repository of all corporate actions that have happened in the company, you've already shortcut the due diligence process that goes into a typical IPO, for instance, right? So you've got all your IPO requirements, hopefully in that company smart contract, and in a finance smart contract, if we build one. So you've got the accounts there. And with that, if you can now take away the exchange features, so how you do order book management, and you can put that into the company smart contract, then you no longer need that exchange to do order management. But that, again, is very far ahead in the future. And with that, I've got a couple more slides that shows that we've actually thought about this, and it's not just me talking about it today. If you guys are really interested, speak to me after this. But I think at this point, I will say thank you very much. Very interesting questions.
All right, thanks very much, Mano. I think we have 5 minutes to spare for any questions. Okay, yes. I'll just hand you the mic so that the live audience can hear.
So the contracts, they are on the blockchain, is that correct? And are they visible to the world?
We are on a private blockchain at the moment. So by default, they are not visible to the world yet. Reason we are on a private blockchain is because we're building an experiment on an experiment on an experiment. So we need to make sure, and what do I mean by that? You've got a blockchain layer, you've got a smart contract layer, and then you've got the digitization of legal layer, right? So we don't feel comfortable yet to publish the smart contracts on the public Ethereum network. And the smart contract logic itself, it's also pretty big at this point. So we would hit the block gas limit in the public network, for instance. So we've got a custom private Ethereum-based network that we run. So they're deployed there. So if you have access to that network, you can definitely see the smart contracts.
So what if somebody wants to verify? If somebody wants to verify something, they need to come to you to view the contents?
Request access to our network. We'll give you access to our network, and then you can view.
But then, does it mean they can view everything on the blockchain?
No, so what you view on the, so that's why I've placed a lot of emphasis on the encryption, right? So what you view is public addresses and logic. But the moment you want to query, for instance, who the shareholder is, for instance, identity-wise, right? You can see his public address, you go to his identity smart contract, and when you say get identity, it will give you a link to an ID file. The ID file, guess what? It's encrypted. So you would know that a specific hexadecimal address owns a specific amount of shares, but that's all the information you know. You don't know who that person is unless you're part of the company or you're one of the verification entity admins.
Okay.
Yeah. So the overall idea is anything storage related, which is your identity information, is stored off blockchain, encrypted, and only computation logic exists in the smart contract.
Okay.
Nothing else. And by the way, private limited companies in Singapore, you could go to Accra, pay $5 and get the listing. So it's not exactly private information.
You can even view the revenue and all this information? For those
For private limited companies, it depends.
For those with audited accounts, I think you can view some financial information inside as well.
Yeah, yeah, indeed. So, yeah. So what we're doing is not it's in line basically.
Awesome. Any more questions?
Yeah. So just from a business perspective, either I go with a normal corporate secretary, right, who runs around and has papers in his hands and files it to one person and the other, and they sign by pen and paper, or I go to you guys and you guys transform it into code. So Why should I choose you over that guy?
Cost of doing business.
But you guys have to transform the entire thing into a programming language, so that's cost, right? And you say that
it's already
cost is
done.
still cheaper.
It's already done. So for a standard constitution, it's already done.
For a standard one,
Yeah.
but
If you're a complex company, yes, then we have to talk about it. So at the moment, this is also sort of the evolutionary process we're going through, right? We're a startup. We're growing as a startup. So we did our seed round. We've got employee share option scheme now, and we also have built that in the dashboard for our startups. So as our constitutional requirements get more complex, we also modify the company smart contract to make it available to them.
okay, then let me ask the follow-up question, which is, if you have one standard contract for a standard constitution, once you go to a public blockchain and everyone can see that logic, they can easily copy that.
Yeah,
So someone else could do exactly the same thing you did without doing the whole experimentation thing.
No, absolutely correct. So I think the one thing we must realize in building blockchain applications is it can never be completely closed source. At some point, you will always have to reveal your code, right? So that's also sort of why we've not gone to the public blockchain, because I would like to go to the public blockchain when everything that we do has been completely vetted, audited. Then we would. Yeah. I think we need to give time
Yep,
to...
yes, time is up.
Thank you,
Thank
thank
you,
you.
Mano. Let's give him a hand. All right, next up we have Chris Hitchott from Digix Global.
You know, there's a big Ethereum meetup going on somewhere else, right?
Yeah, it just ended like an hour ago. Yeah. All right, here we go.
Testing 1, 2. Hello. Is there a clicker? Thank you. Hello everyone. Thank you for coming to this event tonight. My name is Chris. I work for Digix Global, and we are currently... Could you move the cursor slightly so it's not covering the... Perfect. We are an asset tokenization platform that you may have heard of. Basically, we are turning gold into magical money on the internet. And part of this project is a light suite, a light wallet called Spectrum. And today I'm going to talk to you about the technology behind it, the genesis, and basically our logic for creating this product. First, a bit of context. So, hello, I'm Chris. And it all started in Hong Kong. Basically, I went to Hong Kong, did a startup. It was an event app-based web development startup. So if you have a fleet of 500 iPads and you need to update them, it's easier to have a web server and push just a new URL to them or a new update instead of manually reinstalling every iPad. You rent out 500 iPads and you have a single server. If you need to update it, it's a lot easier to do web apps. And by doing that, you get heavily involved in the web development community. Basically, I founded a meetup group called Meteor Hong Kong. Meteor is a web development platform that you may or may not have heard of. Back in 2014, it was the hottest thing on the market for delivering web apps, and since then it's kind of matured, but in my opinion is not the best choice anymore, and I'll explain why. So this is me back in 2014, a little bit slimmer than I am now. But then Frontier happened, right? So Ethereum launched, 0.1, and this was like mid-2015, and it completely blew my mind. It meant that me as a web developer was now responsible for allowing the general public to interact with this magical new blockchain technology, these smart contracts that would otherwise be inaccessible to general population. Now, my job is to make an interaction between them as a web developer. So instead of Meteor Hong Kong, I joined Ethereum Hong Kong, did a few meetups with this guy, Jahan, good guy, and we got a bigger projector to start off with, and started talking about blockchain. Now we have an even bigger projector, so hopefully next time it's going to be even bigger. I also developed this front end called State of the dApps, which you may be familiar with. Basically, it's a curated list of dApps on Ethereum. Currently 366 dApps listed, so have a look. If you want to see how the Ethereum ecosystem is existing right now, this is probably the best place to go. It's a curated collection of dApps, and you can find a various number of gambling and non-gambling based applications. Then I went to, in late 2015, to DevCon 1 in the UK. It was great. I first experienced a talk by these two guys, Fabian and Alex, the creators of Mist. Mist is a Ethereum browser that will allow the interaction of basically general websites to interact with the Ethereum blockchain. And they showed me this idea of an escrow contract where you can deposit money into a contract and allow the safe transfer of assets between different people in a decentralized way. And for me, that was pretty cool. It blew my mind. And Mist was the way to do it at that time. And Mist was based on Meteor. We even contributed to it. We created the internationalization library for Meteor, and that's what they're using in Mist. So I then created a marketplace app for it, such that basically you just have a registry of these escrow contracts, so people can list whatever kind of contract you want, and then trade. It's not like Silk Road in any way. You can build it yourself if you follow this GitHub link and learn a little bit about Ethereum and Meteor. And then I joined Digix. Digix is, in my opinion, one of the cooler projects in the Ethereum space. Basically, it's the idea of taking real-world assets, verifying it through a bunch of different third parties, and then publishing contracts on the blockchain. You take these contracts and then you turn them into tokens, and then the tokens can be traded on the free market, on Poloniex, wherever you want. Clicker. Okay, so Digix did the first crowd sale on Ethereum, chain-based. It was done in about March, I think, 2015, or it was raised a bunch of money, and it was the first DAO. Unfortunately, that word has been a little bit tarnished since, but it was the first, and history was made by doing that. I built the website. We gave Vitalik a t-shirt. And now I'm going to talk about the evolution of what I've been working on in the last year, which is trying to create basically a web-based Ethereum transaction signing interface that anyone can use. It started off with Meteor Light Wallet. Using the Meteor stack, I integrated semantic UI to try and create a reasonable interface that maybe my mum would be able to use to send transactions to different people. But I soon realized there were pretty significant problems with using Meteor as a stack. Basically, including a bunch of crypto libraries is not a good way to, bundle stuff in Meteor. And especially if you have a CSS framework, it requires a lot of calculation. Every time I hit save, it would take about 20 seconds to rebuild the page. It has poor bundle optimization, meaning that, well, a 3 megabyte file with every dependency in it is essentially superfluous when you can use other alternatives that can turn it into a 400 kilobyte file. Blaze, the rendering engine of Meteor, is not performant, and MDG, Meteor Development Group, decided to upgrade to 1.3 and basically break everything. So all the packages that you were previously using were obsolete, unfortunately. So now you have this platform that is not optimized, it's also unstable, and basically if you're building a front-end user interface, it's just an opinionated build system with very inefficient parameters. And most importantly, it doesn't work with NPM very well. I filed an issue last year, in fact, about not interpreting package.json properly. So kekak.js is like one of the core libraries of Ethereum. It's the SHA-3 hashing algorithm. And Meteor just didn't work with it because of this browser field here. They only accept single strings, not objects, for some reason. And thankfully, Alex, aka AXIC, was able to fix it very quickly. But in recent builds of Meteor, it's still not working, and the issue is still open. So a year later, we still don't have the ability to bundle efficiently in Ethereum with Meteor. So don't use Meteor. So the next question is what to use. Well, there's a bit of a battle going on. It's between Angular and React. They're fairly similar kind of community support. In my opinion, there are some reasons to choose React over Angular. Mostly performance. Basically rendering a bunch of stuff in React is a lot more performant because they have this idea of a virtual DOM. I know a lot of you are not developers, so I'm not going to try and explain why that's a good thing. But they have a lot of community packages as well. So in the world of React, you can import a QR code library with ease. You can import basically any kind of component that you can imagine that is useful. Someone's probably already written it, and that's a good thing. Composability of modules is good because, components. It allows you to basically nest things in a way where you have a stateless function where you put in various different variables and it renders in a very defined and specific way, a functional way. And that means it's very testable. And if you combine that with Redux, which is a state management tool in the world of React, you get a lot of benefits and a lot of reliable and, I would say, secure testing mechanisms. I also used Angular before, I didn't like it, and following people on GitHub is a pretty good way of understanding whether or not people are going to be using this in the long run. Turns out I was right. Skip this slide. Turns out I was right. So follow the trend and you'll see that React is basically winning the war right now. So IMO, use React. And now we're in a kind of new sort of environment where first Meteor was the professed thing to use, and now it's all about React. So we have like a new plateau of things to discover. I built the Digix marketplace in React because of this, and you can watch a UI demo on that URL if you want. Basically, this is a user interface for buying assets and trading tokens, not trading, buying tokens from us directly, Digix, and it's all built in React. And the idea was that we would integrate a light wallet into this. So, as you can see up here, this is a hosted node. Now, this is the interface for trading in the Digix marketplace, and typically you would have a hosted node. And a hosted node is basically us. It's just a typical web app where you log in and you do transactions and we process it. It's a back-end Ruby server. But ideally, there's some sort of light wallet involved. Now, a light wallet is different. Instead of us controlling the keys and managing processes, you hold the private keys of your transactions. So you have full control of the assets. This is me about 6 months ago in Singapore talking about why light wallets are going to be a thing. I was right, but I've updated the slide a little bit to say that actually now it's a little bit easier to do non-light wallets, but because, well, the technology has evolved. Essentially, instead of having a 2-hour sync, you now have 20 minutes with parity. There are beta clients available for IoT devices and light wallets and that kind of stuff. So, but I still think there is a case, and I would say a usability case for having light wallets. I've called them zero clients as they're known today. The idea is that you have the key store on the client and you publish transactions to a third-party node, which would then relay it to the Ethereum network. There's no key store that's saved on the Ethereum node as a service. You just keep the keys locally, publish transactions, sign them, etc. So, what are the benefits of doing it this way? Basically, it's way more accessible. You don't need to download anything. There are no hardware requirements in terms of all you need is a JavaScript environment and the ability to run algorithms like SHA-3. If you can do that, then you can sign transactions and publish them to the Ethereum network. And that means that every browser interface, every browser environment is capable of running a zero client. This makes it convenient because you can just visit a website and then have full access to Ethereum and have essentially the same level of security that you would do. There's also redundancy. You can just change your node. You can say, okay, I'm now connected to this guy whose node has failed. Let's switch it and sign transactions in a different way. No problem. Finally, security. You can sign things in a way where you never touch the internet. Basically, you generate your keys offline and you sign everything offline as well. I did a talk about a week ago that explains this a bit better. So, the first approach was to create a product called Digix Light Wallet. And this demo is still available on the internet if you want to try it out. It's essentially a React Redux light wallet application with some nice user interface, in my opinion. You can name your accounts, you can add accounts, single kind of accounts, and download them, delete them, etc. You can sign transactions and publish them to the network, and it's all good. But this was not compatible with the marketplace. It turned out that for various reasons, the marketplace needed to be a standalone thing that didn't involve a light wallet system. Basically, it gets a lot harder to audit crypto when you're doing it in the browser as well as on the server side. So we decided to not have it at all. It also means that we didn't have to maintain a light wallet alongside the main marketplace dApp. There are regulatory concerns when you're like having a main marketplace that is KYC login system and then also having a free reign light wallet alongside it. So it's better to just not have. However, all is not lost. We still got the UX, we still got the benefits of developing it, and we can still implement it later on. And there are various reasons for doing that, right? The Digix DAO is a smart contract that exists on the blockchain, and there needs to be ways to interact with that. So you could do it via various different interfaces through different light wallets. But we wanted to keep everything centralized. We wanted to keep this principle of not invented here, right? So the idea is, if we rely on other third parties to develop the key signing, security, and user experience, then we lose a lot of ability to provide the services that our clients want, right? So feature sets, long-term maintenance. If we rely on a third party and they decide to not do it anymore, then we're kind of screwed and we have to migrate to somewhere else. Premium add-ons in third-party services basically just don't work. And licensing restraints might prevent us from doing things that we would otherwise be able to do. And that's when we realized basically it was up to us to realize this metropolis vision, this vision of accessibility and adoption. A new in-house full spectrum light while it was needed. And that's where Spectrum comes in. So Spectrum is basically a light wallet with a bunch of features. First, the goals. We wanted to make it so Spectrum was available everywhere. That encourages adoption. And the first thing that we wanted to solve was the user experience problem that we currently have in Ethereum. So we wanted to make it such that people can just visit a website and have full access to the Ethereum ecosystem. That's what Spectrum is fundamentally trying to solve. And to solve that, you have to put mobile first, because everyone uses mobile. You have to be able to deploy it on every device, preferably. It has to be unstoppable, i.e. truly decentralized, without any central point of failure, and open source, of course, for security. Convenience should be left up to the user. We want to make it so there's a minimum level of security that users have to take, but after that, they can go all the way to complete offline signing, to having a very basic encryption level. And then finally, a usable interface for dApps. Right now, this is the closest thing we have to a completely decentralized, offline, available interface for dApps. I want to convert this into something that my mum could use, and that she's not scared of. Basically having, it's great for developers, but not for end users. So we need to convert this idea into something that end users can do. So the features. First of all, zero install, very important. Going to a website, having everything available immediately. Deploy anywhere, like I say. It should be available on your tablet, on your computer, on your phone. And ideally, sync between all those devices at the same time. It's difficult to do that in a decentralized way, but it's possible with web technology. We want to have a dApp store. The idea of bundling user interface with smart contracts such that it's not just an individual ABI that you're interacting with. And then finally, multi-chain. So being able to connect to any endpoint and also have this concept of differentiating between the different chains. So for testing, for private networks, for mainnet and testnet. That's an important aspect. So the question was web versus native. Now, Status is one of these, in my opinion, extremely good projects. I think this is potentially the realization of Metropolis. But there is one problem with that. Apps need app stores, right? And if Apple decides that suddenly, well, the dApp that you're deploying in this app is not okay anymore, then we're just going to pull the plug. So you need to be able to deploy apps that cannot be susceptible to this kind of manipulation. Native is stoppable, right? If you create a native app that's based on Ethereum, anyone can pull the plug at any time. And it's not centralized, it's not decentralized anymore. So the only way to solve that is by creating decentralized app stores. And there is a bit of a paradox in the typical web developer community, such that, well, having a native app is great because you just have an app that you open and you can use and it's really user-friendly. And if you have a website, then you have to type in the URL, you have to have bookmarks and remember everything. Well, that's not true anymore. Basically, in the last year or so, we have in the web community technologies that allow us to create native app-like experiences. So this is just a website, right? You add it to your home screen, it feels like a native app, and it acts like a native app. It's full screen, and it works offline. So how do we do it? This is where the non-developers might be slightly, well, hello internet, this is for you. So, the general approach to the technology stack was to make everything completely dynamic. Basically, networks, key stores, storage, interfaces, make it all available for anyone else to produce and deploy. We don't want to have control over it, we're just creating a platform for you to deploy on. The stack we're using requires basic modern web technologies, which I'll go through in a second. First of all, Webpack. This is what replaces Meteor. So Meteor is bad because it's just an inefficient version of Webpack, basically. You can't configure how Meteor bundles stuff very well, and you get a lot of benefits by learning and implementing Webpack. You can take bundle sizes, as I said, from 3 megabytes to 400K through the deduping, ES6 tree shaking, and URI coding of images. There's a bunch of optimization tricks that you can use with Webpack that are not available with Meteor and other build tools. From a developer point of view, you can have location agnostic imports. So in your project directory, instead of importing from a specific folder, you can just say, I want this root thing, and then import that. And one of the major perks is this effortless next generation API thing. So with one line in your Webpack config, you can add resource hints, subsource integrity, which is basically allowing the browser to verify the source of what it's requested through hashes, and then an app manifest, which allows you to create that native app feel. This is what app manifest looks like, and you can literally just add one line in your Webpack config, and you have a real app, and it looks and feels like a native app. So what's the point in having a native app? The UX is at least as good as native UX. And decentralized app stores are definitely better than walled garden app stores because they can't be taken down. That's an important part. Here's an example of a decentralized app store, I guess. This is a token registry. Parity Technologies pioneered this example. Basically, it's just a list of different tokens that you can request and get information about and add into your application. And then we go to the user interface point. Tokens are fine because it's just a bunch of integers, like how many decimals, what's the address. But what if you have components with JavaScript related to it? Basically, you do this. You create a script that takes the particular key store or daplet that you want to turn into a downloadable module, pass it through Webpack and bundle it into a single JS file. You upload it to IPFS, and then you register that IPFS hash into Ethereum, and then you have exactly the same thing that we had before, except now you can download a JavaScript bundle. And that's what we're going to be implementing. Semantic UI is a CSS framework that is awesome. Basically, it allows for that standardized elements that people are used to. It already exists very popularly on the internet. And it's this idea of taking dApps away from the MySpace era into the Facebook era. So instead of having individual custom dApps, you have a very standardized user interface that people can use, and you have components that are predefined, and it allows dApp developers to very easily just compose dApplets that are already understood by their users because of the interface. And you get the benefit of having theme managers on top of that. So you can change the parameters of the CSS, recompile it, and you get a new theme. And because it's a predefined set of HTML elements, you can basically get a bunch of different themes provided that by the community and have your own. So this is a component in React, in semantic UI React. Basically very declarative. You have a form field and an input, and you generate this beautiful transaction signing interface. Very short, very declarative. And this is the kind of component that dApp developers will be using in the future, I think. So Redux, very big topic. Redux is basically a data store for React applications. It's a functional-based system. It allows you to separate the state from components, which is important for testing, such that you can define states for components and then test them for that state, and then decouple that and then test the state itself. So you have very granular unit tests for your UI and your state. It has great dev tools and a bunch of community plugins that we're leveraging for Spectrum. Here's how it works. Like in a typical React application without Redux, you'd be managing state between different components. But with Redux, you have a single store, and when you update the store, it will tell the components which things to update. Here's the dev tool that I was talking about earlier. This is Web3 Redux along with Redux DevTools, and basically you have this slider where you can traverse time. So whenever actions come in, so we've got an XHR update, we've got a method success. If you wanted to debug that, you can just drag it back in time, and you can see what the UI would look like, which is quite powerful. Onto Web3 Redux. This is basically a wrapper for Web3, which I wrote, that implements Redux for Web3. It supports multiple networks in that you can define Ropsten, mainnet, whatever kind of Ethereum-based network that you want. And it promisizes it such that you can have a transaction followed by a promise, a then event, and then continue on without going into callback hell. And you get all the benefits of Redux. This is what a typical dApplet might look like. This is the base token balance, which is part of Spectrum. Basically, when the component mounts, you get the balance of the address, and that updates that single store. So whenever you request the balance later on, such as when you're rendering balance label, it will look at the Redux store and get the value that was given when it mounted. And you can also build in middleware such that you're caching these events. So if the block is the same number, there's no need to do another request. So you can make more efficient user interfaces. If you wanted to send a transaction, you could create a promise chain where you use the same familiar Web3 interface, Web3 eth send transaction, pass in what you'd expect, receive a transaction hash, use the extended waitForMind function, which is a promise, and then return. Once it's mined, you update the balances of both addresses. And whenever those addresses are in the UI, they will update. Redux ORM. So this is what I've been working on the last week. It became very apparent that managing objects and the relationship between different transactions and key stores and networks was complicated if you're writing manual reducers. So implementing an object relationship mapping library helped solve things tremendously. Essentially now you just write a bunch of models and their relationships to each other. You have a key store type, of which there are one or two, for example, v3 or HD. And then you have the key store itself, which includes the encrypted version of that data that has many relationships to addresses, potentially, or maybe just one. In the case of HD, it has many. In the case of V3, it has one. And that address has many relationships with tokens. In return, the tokens have relationships with networks and addresses also. So now you have this, like, what would be a very complicated system defined in an object-oriented way that's very easy to manage using selectors. So if you wanted to get network with tokens, you just write a very simple function, get all the networks, model it, map it, get the tokens, and then pass it into the network's state to props. So basically, a function that turns your normalized state into denormalized objects in ways that your components can very easily use. And the benefit is this is cached, essentially. So unless the state changes, this function won't rerun, so you have very efficient rendering. Web3 provider engine. This is the next awesome tool that everyone that's in the Ethereum space in JavaScript should be using if they're not already. It's extremely underrated. I can't believe it only has 34 stars. But what it allows you to do is compose your own middleware for Web3. It lets you intercept calls and cache, sign transaction, and instead of using like get filter, which is not allowed by Infura, for example, you can replace it with your own RPC calls. So let's take signing hooks, for example. In the signing hooks example, we're creating a new Web3 provider using generate Web3. We're passing in the filter sub. This just allows us to interact with nodes that don't allow filters, which are stateless and not good. We pass in the Redux sub-provider, which is below, and basically it just has this method called sign transaction. So when you sign a transaction in Web3, in Spectrum, you pass a type and the transaction itself. That will then generate an action, and that action can generate some user interface and then return a callback with the private key, send the transaction, and there you go. So now this is how we create this modular infrastructure for key store providers. A bonus hack, if you're working with Web3, you might notice that there's lots of round trips that you do. Don't do this. It's easily fixable, either on the server level or the client. Either set your options cache age, or just send a plain text request, and that will reduce your number of requests in half. Simple trick, but Infura doesn't do that right now. Redux persist. This is the next key element. Basically, it syncs with local storage out of the box. It rehydrates state when you refresh, such that what was previously in local storage becomes your Redux store. And you can create custom middleware. And this is where it gets interesting, because you can create transforms that encrypt that. You can also have migration steps between different versions of your state. So if you wanted to have an upgrade of the app which changes the state, you can migrate. And the really cool bit is having this async adapter. So you can hook in a service that will synchronize your data with some sort of asynchronous process. This is what it looks like in code. In practice, you're gonna, well, in Spectrum, you would hook up a service worker, which is a background process. It's basically one of these new HTML APIs that allow you to run essentially a process that even if you close the app will continue in the background. It acts as a proxy server. You can use it to cache the content. So even if you have no internet and turn off your Wi-Fi and your 3G, you can still open up the app, create key stores, and you can use it for syncing with your service provider, right? Be it Dropbox or Google Drive or IPFS or whatever. And you can write your own logic for determining whether you're offline or online to determine when to sync. And push notifications as well. If you have a server that's saying, okay, you've got a transaction now, you can have a service worker in the background that updates your app and tells the user that you've got one, even if the app is closed. So yeah, these are various service providers that you could attach to. We're going to be releasing this month an adapter for Google Drive that hooks into, basically it will encrypt your data store and sync it with Google Drive, and then you can sync across any different device. The problem with having centralized service providers is that they can go down. So in the future, it's better to use decentralized ones like Swarm or IPFS. Finally, add everything up, and you get this truly decentralized, no central point of failure, but perfect and unstoppable user experience. Finally, the roadmap. So we released an alpha demo earlier this year. We are on the path to 1.0. Our next sprint is going to be for the assets UI. So Digix are releasing on the testnet how to transfer gold bars to each other. And we're going to be implementing that into Spectrum for public testing. HD wallets and the persistence layer I talked about will be there before the public beta release. And then after a security suite and, security audit and test suite and documentation, we'll go for the open source release. And we're going to try and provide a lot of developer tools for people to integrate their own dapplets and deploy on the dapplet registry. In the future, we got a cool bunch of features planned. Number one is internationalization. We want China to be involved. Mass transaction processing. This is a Attores collab. Thanks for this idea. Basically, if you upload, for example, a spreadsheet with 1,000 users, and you want to make a transaction for each individual user, if you wanted to pend each individual transaction, it would take probably about 5 hours. But we're going to provide an interface that allows people to batch those transactions, confirm that they're confirmed in a batch, and then move on to the next one, such that you basically divide the 5 hours into 30 minutes. And this could create a new kind of species of dApp that allows for massive transactions. We're going to open the public dapplet registry afterwards, which will allow anyone to register a dApp. We're going to have like verified and unverified dapplets, ones that we've like audited ourselves. Chrome extension, such that you can visit any normal dApp and sign transactions using Spectrum, and then push notifications eventually. And some premium services. That's it. Thank you.
Much, Chris. Unfortunately, we don't have time for Q&A. If you have any burning questions for Chris, please drop him an email. His email is at chris@dgx.io. Next up, we have Gaurang from Attores.
Hey, go back to the first slide, please. Hello guys, I'm Gaurang. I'm the co-founder and CTO of Attores. So we started this company almost more than 1 year ago. So back in 2015, my co-founder David Moskowitz, he had sold his Bitcoin company. So then I knew him from the community, I met him, and then we started discussing ideas about what we can do in the blockchain space. So we came up with this idea of smart contracts as a service. We have evolved from that time, and now we are concentrating mainly on digital certificates. So at Attores, we are trying to build open standards around digital certificates using blockchain and smart contracts technology. So yeah, I'm going to tell you today about Attores. I'm going to tell you about what problems we are trying to solve, what cool technology we are building. But let me actually give you an overview of the Ethereum and the blockchain ecosystem in general, and then tell you how Attores fits into that narrative. So this was the headline last week. R3 stopped using blockchain. R3 is buying Ethereum for 59 million. Don't get me wrong, I know this is an Ethereum meetup. I shouldn't be speaking about R3, but I just wanted to address this point and tell you that R3 hasn't stopped using blockchain because they were never using blockchain. And I know some of you might not agree with me. They have their own definition of a DLT, that is a distributed ledger, and blockchain. So they say that they are doing DLT, not doing blockchain, to each his own. So this brings me to the Gartner hype cycle. Many of you might know about this. So according to the Gartner hype cycle, I firmly believe that blockchain is at the lowest point in this hype cycle right now. It's right in the trough of disillusionment. But don't fret, everything is not lost. Right now, blockchain only has upwards to go. It is going to mature as a technology, and it's going to grow in the coming years, definitely. And what happened? Yeah. And this is evidenced by the fact that Enterprise Ethereum Alliance was launched 2 days ago. Many companies, that is banks and Ethereum startups like Consensus, they came together to form an industry group around Enterprise Ethereum. So now they want to take Ethereum to enterprises. All these days, over the last 1 or 2 years, Hyperledger project has been dominating private blockchains and enterprise offerings for blockchain. But this is changing now. That is again evidenced by the fact that Monax, which has a product called Eris DB, they also joined the Hyperledger project. So now Hyperledger has an Ethereum virtual machine project. So this actually surprised me last week, because I saw that Monax is joining Hyperledger, and then I saw a blog that Monax is also joining the Ethereum Enterprise Alliance. I'm like, how can they do both the things? But apparently it's possible. So what happened? Yeah. So let me give you a quick overview about the Ethereum Enterprise Alliance and the Hyperledger project. Both of them have some members in common, like JP Morgan, Intel, and Monax, obviously. So what Hyperledger project is actually under the Linux Foundation, and Hyperledger project is under the Linux Foundation, and they incubate different blockchain and blockchain-inspired technologies. While Ethereum Enterprise Alliance is formed broadly to develop Ethereum into the enterprise ecosystem. So today morning we had a discussion with Joseph Liubin from Consensus, and he gave us a good overview about Ethereum Enterprise. So what they want to do is they want to make Ethereum a standard in the enterprises, and want to grow it as an ecosystem in enterprises as well. So now, talking about all these DLT, blockchain inspired things, at Attores we eat BLT and we do blockchains. Okay, so this joke was by Rick. Apparently it's not so funny anymore. So yeah, on a serious note, Attores sits at the top of the blockchain stack. We are not building blockchains, we are not building DLT, we are not even building libraries like Chris is doing. We are building user applications. We are building the UI layer which makes it easy for people to deal with blockchains. When you log into dashboard.attores.com, you won't even know that you're using blockchain in the backend. Sometimes it seems too easy. And that was what we wanted to do from the beginning itself. So let me go into the problem now. What are we currently doing with Attores? So for that, let me take you back to 1995, when David Moskowitz got his really valuable Bachelor of Arts degree in psychology from the SUNY University. And he psychoanalyzes me on a daily basis. We also have a couch right there in our office. So, and he also has an MBA. So when I decided to start this company, he showed me this certificate and I was impressed. Oh, David has an MBA. It's good. I have a business partner at the end of the day now. But I realized that this was a fake certificate. So you are from INSEAD, right? You're doing a PhD. How long does it take an MBA? In 1 year at least, right? Yeah. David is a really cunning guy. He did this in 20 minutes in Photoshop. So yeah, this is not just a problem with David and in Attores. So yeah, by the way, he doesn't have an MBA. I was just kidding. So, so yeah, this is not just a problem with MBAs and fake certificates. It is a global problem. The CEO of Yahoo had forged his certificates. Even the Moldova Prime Minister had some problem with his false credentials. Even at our home in Singapore, IDA has been facing this problem for some time now. So the solution to this is blockchain. People say that blockchain is not a solution to all the problems, but definitely this problem can be solved by blockchain. And why blockchain? So if we use blockchain to issue digital certificates, to issue open certificates, the users, that is the universities and the students, have ownership over the certificates, have ownership over the credentials. Plus, this can also be a revenue generating opportunity for the universities. You can even release your the certificate platform as tokens and have speculative value on that. And also, blockchain virtually has no downtime, as evidenced by Amazon S3 last week, when they were down for almost half a day, and many internet services were affected by that. Also, we can have selective disclosure on this. That is, the student, the user, they can choose what they want to disclose. Suppose you have like a MBA degree, you can choose whom you want to disclose this to. If you want to disclose this to maybe one company and not to the other company, you can do that on your own in a decentralized manner on the blockchain. So this is just a sample certificate that we were issuing out during the Singapore FinTech Festival last year. So we were standing with, actually we were presenting with Neon Polytechnic at their booth at the Poly FinTech 100 thing. And we were issuing these certificates to all the attendees there. So this is how it works. It's not very difficult, it's not rocket science at all. So the issuer, in this case the university or the polytechnic, they come to the Attores web page, they issue the certificate, they create a certificate. I'll show you a demo in a while. So they create a certificate, I put that transaction hash into, I hash the PDF, I hash the certificate and I put that hash into a transaction on the blockchain. This certificate from that point on resides on the blockchain, and it is in control of the student. The student can then select whom he wants to disclose it to or not disclose to. And when now he goes to an employer, suppose Microsoft, for a job, the employer can validate and verify on the blockchain that this certificate was indeed issued by this university to this student. And that's because in the process of creating the certificate, the university is essentially digitally signing the certificate. So you can also share these certificates on LinkedIn by the click of one button or any social media. And you know, people love sharing their accomplishments. Businesses love sharing their accomplishments. And hence, I think this is a really viable idea. And you know, this technology, this idea, it's not just applicable in educational institutions, but in many other use cases. You name it and we can apply it there. So Otonomos is already doing that with the companies by digitally signing the certificates on the blockchain. You can do it in real estate as evidenced by Ivan is not here. So yeah, Everspace. So these guys are already using us for digital signing on the blockchain. You can do it in insurance, healthcare, you can do it in logistics and supply chain and many other applications. So now let me show you a quick demo of the Attores platform. This is about the digital certificates. So an issuer, he logs on to the Attores system, he has a issuer profile. Under that he has a course profile. So you can have multiple courses under this. And under those courses, course profiles, you can go ahead and start creating a certificate. So right now, the issuer, in this case David, he is creating a certificate on the blockchain. So he is entering my information, the date of the issue of the certificate, my email ID and all of this, and it gets updated on the template on the right hand side. So now when he will click create, he will enter a password, that is a seed on in this web page. Right now what we are doing is we are creating a public private key pair in the browser itself. So this helps us not to store your keys. So we don't store your seed, we don't store your keys at all. You are in charge of your private keys in this case. So now the certificate has been created. We also have a verify page where you can go and verify the certificate itself. So the employer can come to this page and verify not only on this page, but they can also verify on the blockchain directly using the transaction hash. And also an added feature, you can just download this certificate in the form of a PDF, just if you want to print it or something. So yeah, now, so what we are doing with this, so why am I talking here today? Because I want to open source this project quite soon. And I want to make it available to the open source community so that developers can start working with me. Because certificates, digital certificates and open certificates cannot be done in isolation. As a company, as Attores, we can only target n number of institutions. We can't target the entire world, obviously. So this needs to be a standard which will be followed by multiple universities and almost all the universities in the world, so that anybody who issues the certificate will have the same thing compatible anywhere else in the world. For that purpose, we are collaborating with MIT BlockCerts guys. So we had a talk with them a couple of weeks ago, and yeah, they are happy to collaborate with us on this point. So what MIT BlockCerts is doing is they are doing digital certificates on the Bitcoin blockchain. But the way they are doing it is a little bit different from how we are doing it. But obviously, they are trying to follow the Open Badges standard, which is again a standard for certificates all across the world. It has been set up by Mozilla Foundation. So they are doing it on the Bitcoin blockchain. We want to do it on Ethereum and Hyperledger blockchain, Hyperledger Fabric. So there's a company called Learning Machine, which is working in close collaboration with MIT BlockCerts. I don't know what's their relation, but they are working in close collaboration. So they have started a trial in Malta where they will be issuing certificates and multiple documents on the blockchain using the BlockCerts technology. As for us, we will soon be starting a pilot. So we're just finalizing all the details. We'll soon be starting a pilot with one of the polytechnics here, and also with another consulting company for issuing digital certificates. Another cool feature, I am going to be integrating with Uport. So why I want, many of you might know Uport, which gives you like a self-sovereign identity on the blockchain. Why I want to do this is because I want to create an Attores backpack on the blockchain. So just in the way that Otonomos has all the company documents with their links on the blockchain, I want to do something similar for all your certificates and credentials. So just imagine, right from your primary school to your secondary school to your JC to your diploma to your degree and any additional certificates, if you have access and control over all of them in the blockchain, on the blockchain, that would be really awesome. So you'll have access to these digital copies anywhere in the world, and you won't lose access to it. So essentially what we are going to do is, the university will issue a digitally signed version of this document. It might be a PDF or it might just be a JSON structure of the file, and it will be highly available to all the people, and you'll have control over it. And this will also give you like a pathway of your professional development, and your employers will be able to verify all of this in a decentralized manner. So that's it from my side. Any questions? Yeah? What's your source code license? Yeah, so I haven't decided that. It might be Apache or MIT license. I haven't decided that yet, but it might be Apache or MIT, anything.
So this certification thing, right? Is that a new business that you're getting into?
Yeah, we have been doing that for a while now.
Or are you planning to use public?
Okay, so now this again depends on use case, every use case. So in case of the Polytechnic, we will be doing a private blockchain, but obviously as huge supporters of Ethereum, we want this to go on the public blockchain. So my philosophy is that you don't put on blockchain what you don't want the entire world to see. So we only put the hash of the information, or we put it in an encrypted fashion. So yeah, currently private for some universities, and depends on the use case. Sorry. Yeah.
So is it a certificate which the user can download and keep it himself? Because browser stores it in local storage.
Yeah.
And how does he export it to a file system?
So yeah, what happens is, no, I didn't get your question. Is your question about the key or the certificate?
I mean, the keys are pretty much stored as certificates, right?
No. So the key is what generates the actual Ethereum transaction.
Okay.
So it digitally signs the certificate. Behind that, we also create.
I'm talking about the digital certificates, the PKCS 12 or PKCS 7.
Yeah.
So,
that certificate is different. So in our case, when I say digital certificate, I mean a PDF copy, which is digitally signed by the key.
Okay.
That's the idea.
So I want to ask that if I'm an employer, so how do I verify this certificate is issued by the Nanyang Polytechnic?
Yes.
And this.
Yeah, that's a really good question. So as I told you, every certificate has a transaction associated with it on the blockchain. So you can easily find the transaction that is associated with this certificate, which is essentially a digital signature of the certificate. And you can see who created or who initiated this digital transaction on the blockchain. And that public key can be associated with the university or the Polytechnic if they publish it on the on their own website or in their social media, because public key can be published anywhere. Also, there are some other ways of doing this. Keybase.io wants to do this as a reputation system. So they want to tie your public key with all your social media accounts and give it some kind of reputation. So there are multiple ways of proving the ownership of the key with the institution, and the institution can be tied to the certificate by the transaction itself.
Verify the key on the certificate. I cannot see exactly the document on the Ethereum system.
No. We can't put documents on Ethereum blockchain because it's not feasible.
Yeah. All right. I guess that's a wrap. Thank you very much, Gaurang.
Thank you.
So the three speakers are still here with us today. We have about 15 minutes left. If you wanted to ask any questions, feel free to approach them. And we would like to thank SG Innovate for hosting this event today. SG Innovate is wholly owned by the Singapore government under the purview of the NRF, National Research Foundation. It has an emphasis on science and deep technology, bringing together partners from the private sector, institutes of higher learning, and research organizations as part of Singapore's broader ecosystem of innovation. So SGI also connects entrepreneurs with support for business plan development, sources of funding, and go-to-market efforts. Once again, thank you for attending. Have a good night.